Alright, so I have a VCR DVD combo unit, bro. And I got this from the Goodwill. And I go to Goodwill to see maybe if they have things that are broken or trashy looking that I can tinker with and restore, or whatever the case may be. And I just happened to see this, man. But to my great surprise, I got it home and it doesn't work, which is awesome, bro. It does not work. It's like it doesn't have any power at all. And it even has a tape stuck in there. So we are going to try to fix this sucker. That's what we're going to do. We are going to try to fix it. And I'm very excited, dude, to try and fix a cheap Toshiba VHS DVD combo. Oh, you know what? I better unplug this bad boy before I get electrocuted. All right. Does the front panel come off? All right, the front panel came off. Can I get to the power button now? So this is the power button right here. So I wonder if I have any voltage on said power button. Let's see, can I take that out and get to the back of it? I took the power button out and the solder joints look okay. How does this button work? So is it open from here to here? No, it's a short from there to there. What is it from here to here? It's a short from there to there. So from here to here, is it a short? It is. From here to here, it's a short. Well, dude, what? From here to here? Bro, come on, man. Oh, you know what? Well, I'm a moron. Why don't I just take and, like, try these pins right here to see if we got voltage? Yeah, we're not getting any voltage to the LED or the power switch. Let's continue to try to disassemble this thing and figure out. So I unplugged it. Let's check our fuse. We got a fuse here. One of those old school fuses. And the fuse is good. So we know we don't have voltage. We know we don't have voltage coming to the power switch. Do we have voltage across the two wires? Let's make sure we're not going to short anything. Let's put this on AC volts. I should have 120 volts coming in. And I do. And then that 120 volts should be felt to here. And it is. And it's felt on the other side of the fuse. And it looks like these 4 diodes, maybe these 4 diodes. Let me find something to point with here. Maybe this is our full wave bridge rectifier, these 4 diodes. Let me go ahead, just go ahead and take the this out. Yo, you know what? That tape, dude, how you get this tape out? The tape is causing me to, there's a screw, I think. Oh, look at the bottom of that. This is the big cap right here. We have 166 volts DC. I don't see a rectifier, I don't see a rectifier. So I'm assuming that's what these 4 diodes are doing. And so far, those 4 diodes are 100% okay, which we kind of know they were because we were getting 160 something volts on the big cap. So I noticed this white boundary that goes around, and it comes between this transistor or this transformer right here and over to here. So I'm fairly certain we were getting 165 volts or whatever on this cap. So I'm pretty sure that everything in this white boundary, it would be considered high voltage. And everything on the other side of that would be your switched DC. This, you know what I'm saying? So this is something, and I don't know what, but something I'm guessing is telling this thing to turn on and turn off at a specific frequency, which causes this thing to output little pulses. And then on the back side of this, it's being rectified again, maybe by this big honking. I mean, there's so many diodes, dude. There's like 4 trillion diodes on this board. I'm pretty sure this is the full wave bridge rectifier. These are just set up, and I can't remember the polarity of that thing. I've researched it before, but we know that this is DC. It's filtering DC. So yeah, so we should have voltages after. It's pretty cool how they put that line around there to help you segregate your high voltage from your low voltage. But this doesn't have a feedback, it doesn't look like, because I don't think this thing is being controlled by an IC. Because if we flip it over, unless one of these ICs, what does this IC do right here? Let's see what that IC is. PT6313 TAC S, Princeton Technology Corporation. It is a vacuum fluorescent. Oh, that makes sense. That's right. Here's the fluorescent. Okay, that's not what we're looking for. This is the vacuum fluorescent display is right there. Okay, so that's what that does. What are these little chips right here? Never gonna be able to find those, guaranteed. Bro, I can't even read that. LX908A. Yeah, I have no idea what that is. Alright, so that 167 volts is being felt on these pins. This is the input to that transformer. So I need a ground. Maybe this can work as a ground on the shielding of the deal here. So am I getting any type of output on this transformer? Nothing there. Of course, I don't know what that would be. I don't know if it would be AC or DC. Because this would be ground, I would assume, on this side, on the high voltage side, but I don't think it would be ground for everywhere. Okay, so let's switch over to AC. I'm getting something. .6 volts, 0.9 volts, 1.2 volts, 1.9 volts, 1.7, 1.9, my hand's in the way, I know, 2.6, but again, I don't know if that's, why would, I need ground. Ooh, I see ground. So maybe this is a ground for this side. There we go. So this is ground on the low voltage side, I think. And I've got it set to DC. So we're getting 2.5 volts. 2.5. Nothing. 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 So I'm coming right out of that transformer, but I know that some of this, I'm assuming something's switching. This is a switch mode power supply, it's just old. So I think, based upon, so you notice that you have your high voltage. You have your high voltage area right here, right? And then the output or the filter DC that you find in your cap, it's felt on the input pins to this. I think they call that a flyback. It's a flyback circuit. And so essentially you have something on this side turning on, it's pulsing and then turning off. And when it pulses up, this coil charges, and then when it goes down, this coil discharges, and it discharges into the output windings of the transformer. And then those output windings then are rectified by either both of these diodes down in here, either both of these diodes or this big honking diode right here. I would assume it's this big honking diode. And so when we check those diodes, and the smaller one is on the bottom and the bigger one is on the top, we can find these diodes. We can find these diodes right here. So if I go this way on this diode, we're getting 0.5, I guess. And cathode, as you can see, is right here. So this is correct polarity for checking the diode. We're getting like 0.1. On the one above it, which is the big honking diode, we're getting 0. And when I reverse the leads, we're getting 0. And I don't think that's right, because this, you have to rectify the voltage that's being felt out by, you have not AC, because it's not a full 360-degree sine wave, but it's like these little pulses, pulse up, pulse up, pulse up, pulse up. This rectifies it, and then it charges these filtering caps, whichever ones, I'm not sure exactly which ones, but, and then you get a smooth output DC on those caps. And like, I'm fairly certain we're not getting any voltage at all. We should have DC voltage. Where was my ground at? I found a ground earlier. It's right here. And then those diodes were here. I'm not getting anything. And we're getting nothing. We're getting nothing. I think that diode is bad. The big one is bad. You guys know that I'm wrong often. So let's try to get that big rascal out of there. We're going to try to pull it out. Where'd my pliers go? Alright, we got it out. So now we're going to test it out of circuit to determine if it shorted or if something else was shorting it. So let's cut the multimeter on. Let's find the probes. So I don't think this was my faulty deal. Or was it? This is reverse biased. No, I think that diode's good. So something else, let's put that there. Something else must be shorting that. Oh, they even have it written on the board, man. I just noticed. All 5 volt, all 1.2 volt standby. Ground. I guess that's why you should like inspect things before you just start jumping in. So that should not be shorted though, I didn't think. I shouldn't read a direct short across that, man. That's crazy. What could be shorted? So the positive side goes there, which makes sense, right? Because I'm getting a positive voltage. I'm getting oh, you know what though? There's multiple. There are multiple outputs to that transformer. So then that means that depending on the number of windings at a given point on that transformer, it's going to produce a different voltage. And that different voltage has to get rectified. Like for example, as you can see right here, you have coming off of this winding here, it comes to a diode. And it's a positive pulse, or it's a positive waveform, forward biases the diode, and then the diode turns on. But none of the diodes seem to be shorted except for the one. That's just crazy. That's an absolute dead short. So where does it go? It goes to a capacitor, looks like. And I can't imagine the capacitor shorted, right? That wouldn't make sense. Not an electrolytic capacitor. I mean, it's definitely 0 ohms across that capacitor. So this would be ground, right? Because that says positive. And that's absolutely ground. And it's a dead short to ground across that capacitor. What else is, oh, here we go. What's this thing right here? Here is a component, oh, that's a diode. That is a diode. And that's 0 across that too. Dude, this thing is just shorted all up. You know, what if I inject voltage? It's a short. I mean, what's the worst that could happen? Alright, so we're going to do some voltage injection. I've got a ground hooked up. I'm going to probe on the cathode side of that diode, and we're going to see if anything gets hot. So I think something's getting hot right here. So something in here. Right in here. Let's flip this thing over and see what is in that area. So it was right in there. Miss. Oh. Oh, I see. I see. Let me show you. So I think that little diode, that little Zener diode, is in parallel. It is in parallel with that capacitor, and that capacitor is the filtering cap, it looks like, for that rectifier diode. So we're going to try to get that bad boy out of there. Sorry, I didn't switch the microscope. So I basically just desoldered the legs of the diode and got them free. So now we're going to flip it back over. Alright, it's out. Now, let's see if we are still shorted on the diode, the main rectification diode. I don't know if we're still shorted. My lights are all blinding. So the diode goes from here to here. Are we still shorted? No, we are not shorted. Okay, we found the faulty component. Now the question is what type of diode is that, bro? I mean, I know it's a Zener diode, but what voltage, what, you know, I mean, what happens if you take it, leave it on there, or leave it out and power this thing up? So now we can put this big diode back in there. Now we need to figure out what voltage rail that's supposed to be. I think it's the positive 5 volts. What would we need? Would like just a 5 volt Zener diode? Is that what we need to clamp the voltage to 5 volts? I would assume. But you know what they say about assuming. Let's slide this out the way for a second. Let's just make double sure that this diode is indeed shorted. It is. Yeah, it's shorted. I think that's a necessary component because I think that's what actually clamps the voltage. Or perhaps it's there to any transient spikes it sends to ground. Maybe that's what it's there for. So maybe generally the rectification diode and the capacitor will give you 5 volts. And if there's a surge, that Zener diode will short that surge to ground. So that's possibly what it's there for. I don't know though. I'm going to have to ponder and see if I can't find a suitable replacement part. Alright, I got it plugged in. As you can see, the green LED is on. I want to measure the voltage on that rail to see exactly what I'm supposed to have there. So I'm going to come to ground, which is here. And that Zener would have been here. So that's 29 volts. Dang, bro. 29 volts. Holy cow. Okay. I didn't realize it was that much. What was that, positive 29 or negative 29? I don't want to run it too long without it. I'm just trying to figure out the correct diode to get. So, no, it's 13 volts. 13 volts. Okay, positive 13 volts. Let's see what happens. Let's see what happens if I'm going to plug it back in and I'm going to turn it on and see. All right, green LED's on. Yeah, okay. I guess it's working now. So that's positive 13 volts. Because it says 2 AL. Oh, 12.5 volts. Not, I was looking at, I thought that said 1.2, but it's actually, oh, let me, right there. You'd think after videos I'd know. But it's always on 12.5 volts. That's what it's supposed to be there. And that is what is there now. It's 13 volts. So then what do you get? Do you get like a 13 volt Zener diode? Is that how you spec that out? All right, so I bought a pack of Zener diodes and I bought some 12 volt 1 watt, but I'm actually going to use, I think, 13 volt 1 watt. That way that diode clamps the voltage to 13 volts. That's, if anything goes above 13 volts, it will not allow it to pass. Now I got to take all of these out to find the correct one I need. 13 volt, here we go. So this is the one that we need. Let's get one of these out here. Make sure, right? 13 volt, 1 watt. So I'm guessing we need to bend this bad boy. So I think one thing I do want to do is, out of curiosity, I want to check the voltage. Let me make sure I soldered it in there correctly one more time. I did. And let's make sure that it is not shorted across our big diode. It is not. So diode is soldered incorrectly. It's a 1 watt 13 volt Zener diode. So one thing I do want to check is I want to use the oscope to see what the waveform looks like on one side of that big diode, and then what it looks like on the other side of that diode. Alright, so that diode got shorted somehow. Do I need to go with a larger? Let's try a 15 volt, I guess, or a 15 volt 1 watt. Or perhaps I need a higher wattage. Let's check this before I friggin' put it in there. So this is reverse bias. And it's open load. This is forward biased. And it's 0.7. Okay, so that should be sufficient. So 15 volt. Alright, let's see if it shorts it again. Okay, it did not. Alright, it did not. Now, so maybe 13 volts, because it was actually 13.6 volts when we measured it the other day, and that might be because the cap right next to it's degrading. I'm not 100% sure if the cap's degrading and allowing 13.6. Perhaps I should pull that cap out and inspect it. I'm not really sure. But I do want to check the voltage with the oscope. I want to see what it looks like, you know what I'm saying? So I'm going to solder a wire to the ground. Or is this ground? This was ground. This is after the diode. Notice it's a nice smooth DC. So I'm going to go ahead and put this back together and see, and then we'll test it and see if it works. I still don't know if anything else on it works. So, all right. So I got my my little composite to HDMI. So I think it's on. At least the green light's on. I hear something in there doing something. So what happens if we, the Maiden City and the Doherty clan? I don't know what that's all about. What happens if I put this in here? Oh snap. It's playing. Alright, now if I eject this thing, if I stop it, how do you stop it? I don't know how to stop. How do you stop? Oh, there's buttons. And if I eject it, how do I eject it? You hit the same button again. Alright, it ejected nice and smooth. Let's put a DVD in. No idea if the audio works. So let's open the DVD tray opens. Let's close it. Disc is spinning, so it's reading. Not getting any video out. Oh, there you go. You have to click the button to switch it to DVD. Well, there you go, man. There you go. She is all fixed up. Pretty cool. Pretty cool. So yeah, I'll put this back together and I guess try to sell it. I reckon. I don't know if anybody will want to buy it, but anyhow, that's it for this, man. I had a ball working on this. I learned a tremendous amount. Anyhow, y'all be good.